All right, boys and girls, welcome back. This will be a pretty quick 5-minute lesson on the volume of pyramids and cones. Why are we learning about these at the same time? Because they're very similar. Not similar in a math sense, but similar in the sense that they each have one base. And we name the pyramid after the base. So if we wanted to do, let's say, a hexagonal pyramid, start with a triangle. Draw the beginning of a hexagon, and then dot what you can't see. Okay, and there you have a hexagonal pyramid, kind of. How do you draw a cone? Start with an isosceles triangle without the base, curve the base, dot the back. Maybe draw a radius if you want. No, I don't like that as much. Okay, next. There are simple formulas for the volume of a pyramid and cone. The volume of a pyramid is 1/3. Capital B is the area of the base. And remember, the height has to be perpendicular to the base. And then here, well, a cone is kind of a specific type of pyramid, but we know what shape the base is. The base is a circle, and that's why it's 1/3 times pi r squared times h. Okay? Okay. I wanted to go back. What this means, you might see this. If you have a cone and a cylinder, how many cones, and they're the exact same dimensions, how many cones can you pour into the cylinder? Exactly 3. That's where the 1/3 comes in. So that's kind of wild. If you have a pop can and you have a cone with the exact same base and height as that pop can, you can dump exactly 3 of those cones and it will fill the pop can to the lid. 3 cones in a cylinder. That's the important part. All right, so now let's see which one's giving you a better deal. We've got to find the volume of each of these. In order to find the volume, we're going to need the height. So we're going to have to use Pythagorean theorem for that. Half of the diameter is the radius, so that's 5. So this height is going to be the square root of 15 squared minus 10 squared. I'll do that real quick, unless someone's going to help me in the audience. That is 11.18. So that's the height. Oh my gosh. Oh, if this thing just had an undo button, I would be better at life. So this height is 11.8. Let's find this height. Well, this is going to be 3.5. So this height is going to be the square root of 12 squared minus 3.5 squared. Which is 11.47. So very similar heights. I don't know. I'm thinking the smallest the better deal here, but let me just go ahead. The volume of the large one is going to be 1/3 times pi times 5 squared. Oh, that 5's being squared. Maybe I take that back. Times 11.8. So pi times 25 times 11.8 divided by 3. So you get 308.93 cubic centimeters. And then the volume of the other one, the small one, is going to be 1/3 times pi times 3.5 squared times 11.47. And that you get 147.13. Ooh, this is going to be close. So now we want to compare that to the cost. So if I divide it by cost, the red one is 308.93 divided by 5.89. So you get 52.4 cubic centimeters per dollar on that. And the other one is going to be 147.13 divided by 3.49. This is going to be 42.16 cubic centimeters per dollar. And so the better deal, as usual, is the large. Buy in bulk. Drink milkshakes. Whoa!